In this video, we're going to talk about Java classes. The first thing you need to know is that object is the root of the inheritance hierarchy. So what that means is that no matter what, you always have object as a superclass. So for example, you might have class list and not apparently have any superclass for list, but in fact, object is a superclass of list. An object defines a number of methods, such as the equals method, that apply to all objects. It provides a default implementation that's normally not particularly helpful, but which you're meant to override. And the neat thing about having an object as a superclass is it allows you to create collections or generic collections of objects, such as lists or hash tables. So here I have a class list, and you'll see I have several functions for insertion, for getting the front item in the list and the tail item. But you'll notice that every object that is inserted is the generic object. So I could insert a string or a user-defined type like a stack or an integer object, although I could not do Java primitives. It has to be some type of Java object. And then I could retrieve those objects using getHead and getTail. And then I could downcast those objects to the appropriate type, like a string. Originally, Java had only generic object collections, but they later decided that all this downcasting was annoying and bothersome, and so they re-implemented generic templates just like C++ has. The second thing you need to know about Java objects is that they are always heap allocated. They cannot be allocated off of the stack. So in Java, when you have a declaration, say stack S, what that does is on the stack, it creates a pointer for 8 bytes depending on the architecture of the machine, and initially it is null. In order to actually have a stack object, we have to allocate it off of the heap. So the second statement will create a stack object and it will make S point to it. Notice that is very different from C++. In C++, if I had this declaration of stack S, then instead of having S be declared off of the heap, instead we would have S actually being a stack object on the stack. And if we wanted S to actually be allocated off the heap, we would create an explicit pointer and then say S equals new stack. Okay? So you need to get used to the fact that all objects in Java are stack allocated, and that was for security reasons so that you could never have access to Java pointers. You also have to be careful because of this fact. So first of all, when you access the methods or fields of a stack, you use dot always. So for example, s.pop might pop an element off of the stack. The second thing you need to be careful about is what happens when you do assignment. So you can see here we have some code that declares two stack variables, A and B. And if we were to put a little stack in here, stack frames, we would see that maybe this is the stack frame for main, and we would have A and B, and A is null, and B is made to point to some stack object. And this statement right here pushes 3 onto that stack, and now we set A equal B, which means that A now points to the same stack object B points to, which is different than in C++, where a copy of B would be made and assigned to A. So now when we say A.push 5, in fact, 5 gets pushed onto the stack object to which B points. So now both A and B point to a stack that has the contents 5 and 3. So that's one difference from C++. Another difference that you need to be aware of is because your objects are pointers, you need to make sure that when you compare them, you use the dot equals method rather than equal equal. So going back to our slide for a moment, let's say that we declare two strings. String A equals hello, and string B equals hello. And now we try to compare them like we would in C++. And because they have the same value in C++, this would yield a true result. But in Java, this will yield a false result, because even though A and B both have the same contents, they point to different objects. And so this comparison, A equal B, will fail. If you want to compare two objects for equality, you need to use the equals method. Remember, that is a method defined by the object superclass and inherited by all subclasses. If you want to compare two strings, remember that you would use a.compare B, and that would return a negative number if A was less than B, 0 if they were equal, and a positive number if A was greater than B. Now, object does not define a compare method, only strings do in certain other objects, because it's not assumed that all objects will have a way of ordering themselves, whereas it's assumed that all objects have a way of comparing themselves for equality. The next thing we're going to talk about is instance variable declaration. And there's 4 things we're going to cover. The first is how you initialize variables in Java. It's a little different than in C++. So in Java, I can initialize variables directly. I can say int size equals 10. And that will assign a value of 10 to the size variable. Remember, in C++, you can't do that, although in the new, I believe, 2011 standard that has become possible, but in the older standards you had to use a constructor to do it. In Java, this initialization of the variables occurs before the constructor is called, so you can assume that when the constructor is called, that these variables have already been initialized. The second thing is that if you want to make a variable public in Java, you have to prefix it with the public keyword. You may remember that in C++ the way you did it was to say public colon, and then any declarations after public were public until you ran into another accessor method like private. In Java, it applies only to that variable. So if I had int top equals 0 like this, top would be not public. It would have something called package level protection, which is the default protection in Java, not private. For the time being, package protection can be taken to be private, but when we get to packages, you'll see there is a subtle distinction between package level protection and private. The third thing that you can do with a instance variable is you could declare it static. So we might decide to have some constant for a stack, let's say max size. And by declaring it static, we're saying that it is a class variable which is shared by all instances of stack. So if any of them modify max size, then all instances will see a change to that. And then if we wanted to make it a constant, the way you do that in Java is you use the final keyword. And you can do that with either an instance variable or with a class variable, though obviously if it's a constant, you probably want to make it be a class variable. In fact, because final is essentially making a constant, and it makes no sense to share this variable or to have an individual copy, then you can omit the static word. So if you simply say final int max size equals 10, then it's also considered a constant. However, if you want to actually have this constant be visible outside the class, then you're going to have to actually declare it static. So inside the class and accessible only inside the class, this version is fine. But if you want to have it be available outside the class, a quirk of Java is you have to say final static int max size equals 10. So we've already talked about how instance variables can be assigned values before a constructor is called. Also before the constructor is called, we can have an initialization block execute, which is a piece of code that can do further initialization of variables before the actual constructors are called. So when an initialization block is called, the variables have already been given initial values. And if we look at some code, here is a sample initialization block for the class random values. And you can see that I have initially declared a variable called random nums as an array. And notice that an array is an object, so I have to assign it an array object, in this case of 10 integers. And then I have an initialization block, which you can see is simply iterating through the array and assigning each element of the array a random number between 0 and 100. So the order in which things are done, again, is first variables, instance variables are initialized. Then an initialization block, if it exists, gets executed. And finally, the constructor executes. It's okay to not have the initialization block. Many classes do not. The advantage of an initialization block is that it is always executed. If you wanted to have a similar piece of shared code in C++, you would have to define a zero-argument constructor and then have all of your other constructors call this piece of code, or alternatively define some function method and have all of your constructors call this method. In Java, by just having one initialization block, you don't have to remember to make this call. A second thing about initialization blocks is that you can also have a static initialization block. So you're allowed to also put the keyword static before an initialization block and then have some code in there. I must admit, I've never used a static block, but when the class is loaded by the class loader, this block of code will execute and do any initializations that you wish to do, although it has to be done on static variables only, since you don't have an instance at that point. Next, we have something called the Finalize method, and it replaces C++'s destructor method, but it is different than C++'s destructor method and frequently a source of some confusion. So the Finalize method gets called when the Java garbage collector garbage collects an object, and that happens at some point after the object no longer has references to it. But you cannot guarantee when that Finalize method gets called. Now, a signature is void finalize. And then whatever you want to do. And typically you would release certain resources at this point. Now, you should not, and I will put this in red, not call finalize yourself. This is a frequent mistake because you think, okay, I'm done using the object and I want to make sure that these resources are released, so you call finalize. The problem is that finalize will get called a second time when the object is actually garbage collected and could easily fail, maybe because the resources were released, you no longer own the objects and you get some kind of exception. So never call finalize explicitly. If you need to release resources when you know that you're no longer going to use the object, for example, in a graphical interface, when I'm destroying an object, I may want to remove the object's image from the display. Just create another method. So you could call it, for example, void destroy, and then you could call that explicitly when you knew the object needed to be removed from the display. Finally, we have nested classes in Java. And just like in C++, you are allowed to have nested classes in Java. So as an example, this is not the preferred way of declaring a list, but I might decide, okay, the only place that I use a node is inside of the list, and therefore I'm going to declare the node class inside of the list class. And this is perfectly fine for you to do. If you do it, then any instance of a node can see any instance of the outer class. So if here in list I have something called head, that means that any instance of node will be able to see head. An important thing to note about nested classes is they're only meant typically to be used within the class itself. Now you'll see exceptions later on in the course, but for the time being you should assume that the reason you define a nested class is because no outside class needs to use it. And the only class that is capable of creating instances of an inner class is the outer class. So here the only class capable of creating an instance of node is the class list. And if we were to, when we compile list, you would see that there would be another class called list $node.class, and that is how your inner classes get compiled, is by using the $ as the delimiter, and then the outer class first, and then the inner class name. That completes the video for classes.